Okay, so we've got this infinite line here, infinite wire with a constant current, I, and I'm assuming here my current is flowing up. I want to find the magnetic field at distance r away from the line. So first we have to use the symmetry of the problem to realize that using the right-hand rule, B has to go in circles around the line. And at a certain distance, r, B should be constant in magnitude around that distance. It wouldn't make any sense for B to be bigger right here than it is right here, because the line goes on up and down forever, so B should not depend on height. The only thing it can depend on is distance away from the line. So in magnitude, B is constant at a distance r and goes around in circles. So right here, my B vector would point out here. So I'm going to build an Amperian loop that looks like B. It's going to be a circle. So I'm going to draw this circle. An Amperian loop is a line, a closed loop. And that could be rectangular, it could be circular, it can be any shape you want. In this case, I'm choosing a circular shape, and I'm to also choose a direction on that loop. And I'm going to choose the direction that goes around. If we were looking at this from the top, if the current were flowing into our eyeball, the loop would be going around counterclockwise, the same direction B is going. So my little DL vectors are vectors that point in the direction of my loop, unit vectors. I have chosen those so that those are parallel with B. Then Ampere's law says the line integral around your loop, I should have drawn that little circle with the arrow here because this is a loop integral. B dot dl is supposed to be mu naught times the total current that flows through the cross section of that loop. Well, since B and dl are always parallel, and since B is constant, B dot dl would just be magnitude of B times magnitude of dl, which is just dl. I can factor out that magnitude of B. The integral around a loop, this again should be a loop integral, of dl is just the length of that loop. That's what this means. How big is this loop? Well, it's a circle. That's 2 pi r. So 2 pi r times magnitude of B should be mu naught I. How much of my current flows through that loop, through a cross section that loop covers? All the current. So I. So then just divide magnitude of B is mu naught I over 2 pi r. So the magnetic field drops off like 1 over r. We know the direction. We really should write here, because it doesn't say find the magnitude of the magnetic field. So we should write B goes in loops around the wire. And if you look at it from above, those loops go counterclockwise. And here's the magnitude.